Importing BIMxml created from the Onuma system into Revit. In the Onuma system, there's a plugin section on the right side where you can download various plugins. We're going to select Revit 2013 or 2012, download it, install it on the Onuma system, then go to your project in the Onuma system. Once you have the Revit plugin installed and set up for Revit, go to your scheme. And from your scheme, there's a couple things first. In this particular scheme, the Design This Clinic owner request, there's an attachment of a custom library family that goes with that Revit file. So we have two versions, a 2013 and a 2012, that's attached to a template file. Download that and either install the library and family or start from the template that will have the library attached to it. So we're going to go ahead and now go to our project in the Onuma system, the one that we've actually designed, and it's ready to be exported, and we're going to go to the export button to actually grab the spaces. That you see the spaces on the plan here, but there's actually spaces, and there's actually equipment in these spaces because these started from a template of requirement, typical template for spaces for a medical clinic like this. So we're going to export. In the export options, there's export to BIMxml for Revit, and you can choose which version of Revit you're using. Export, include the components, download the BIMxml file. So now you have the BIMxml file that was created in the Onuma system on your desktop or in your downloads folder. Launch Revit, and from Revit, the template file that you've loaded earlier, they have the actual families loaded into. We're going to go and do a couple things. One is we're going to go to the add-ins folder since the Onuma plugin has been installed. Now there's a plugin for importing BIMxml. Select the XML file and choose including the components. So that's the furniture, and there's 1,327 here. We're going to hit import. Depending on the speed of your machine, the number of objects, and other factors, it's going to vary. The import time will vary. It may take a few minutes, a little bit longer for a larger file, but just let it run. And you might get some errors about alignment of spaces or rooms. Ignore those, and you'll have this. You have successfully imported a BIMxml file. The errors are typical for the alignment errors that would come even from other IFC files, so we're just going to ignore those and go ahead and export the BIMxml file. Import the BIMxml file into Revit. The first look of it looks like this. There's a couple things. Go to the floor plan, the floor levels, the views, and select the lowest view. The one that came in from the floor setting in Onuma. The other level 1, level 2, and site are default, but if you select your floor, then the space or room names will show up, the tags. And so you'll see the actual space that started in Onuma now. That's with a room separator line in Revit. It's still, the building is not designed, but essentially you have all the program elements that are needed from the owner in Revit now, including the equipment inside the space. And if you look at the attributes of the room or the space, there's actual names and attributes related to the individual spaces. Room separator lines are dividing the spaces, but there is an actual room tag. And if you look closely at the equipment too, you'll see that there's equipment in each room. Some of the equipment actually doesn't have the right shape, like you'll notice this wastebasket here. The reason for that is a lot of these objects for this particular client's family of objects have bounding box areas that need to be, the visibility needs to be turned off. So you turn on the visibility settings in Revit and select the setting for specialty equipment. It's under specialty equipment, and there's one called equipment space. That's the bounding area. So just turn that off. Once you turn that off and hit apply, then you will actually see the equipment plan. There's a wastebasket now without the bounding area around it and all the other furniture. So this is the correct view of this particular template that started from the DoD MHS clinic templates for healthcare planning that were linked in the Onuma system. So now not only do we have the bounding box of the equipment, but it actually went and grabbed the right object from the family. So if you look at it in 3D, it's not just bounding box areas, but actual template objects with the actual geometry. In 3D as well, there's also the bounding box that needs to be turned off. So the same thing again, if you turn off the visibility setting on the specialty equipment, open that up, select equipment space, override, turn that off, hit OK. And now the block that defines the bounding box will disappear in 3D, and now you actually see the actual objects that came from the DoD MHS templates, but actually originated in Onuma. So in Onuma, when we saw these objects, they were blocks, but they were actually tagged to the correct object in Revit. That's why when we export from Onuma into Revit, it goes and grabs the right family object, not only the object, but the actual attributes related to it. So if the attributes were associated with the object, on the left side you see the actual attributes about the mark number, for example, and the IFC GUID that came from the model that started in the Onuma system now. So the end result of this is that in the Onuma system you could rapidly configure, do blocking and stacking with spaces, and if those spaces are prototypical spaces with the required equipment, when you export them to Revit, they're ready to go for your more detailed design work with the right elements in the space and the right attributes related to the spaces and the objects, the right properties that are associated with each of these objects that came from the client requirement. So this is a pretty powerful process because you can very rapidly get the beginnings of a design going in Onuma and then opening them up in Revit. Let's take a look at the floor plan once more. So like we said earlier, the spaces or rooms are separated by room separator lines, which define the net area requirements of that room. In Revit, you can start to create, we've grabbed the wall object now, we're starting to create walls that would define the design that would work around these rooms. And obviously this needs some back and forth work when you're doing the design work. But the great thing here is that once you start putting in the walls and you already have the objects that came from the client requirement database, you can actually turn off the room separator lines and allow the actual room or space object to fill in the space between the walls. So here are a couple of quick walls we've created around these spaces, rooms, and now we can actually start to design the building based on those client requirements. And the data is still linked back, the IDs are still linked back to the Onuma system, so later on in other lessons we'll actually see how we can actually compare this design against the original program requirements that came from the client, including looking at the equipment. So now we're going to turn off the room separation lines since we put in the walls. So what's happened here is that we put the walls around the rooms or the spaces, turned off the room separation lines. The actual space names are still there, and now you see an actual room that's actually filled in to the walls with equipment in the space. And obviously this needs some more design work when you start actually reconfiguring the shape that came in as a default from the owner. And it's all, obviously the 3D elements are all still there, so you quickly can get from conceptual program requirements with the actual client data into a design model like in Revit.